For example circuit number 5, we're going to be looking at using some circuit side controls for your various programs. In this case, push button switches to determine what the output LED will display. So this circuit is going to have two high value resistors, two push button switches, and then an LED for output and a current limiting resistor with it. So first we're going to wire in the LED because that's nice and simple. So the LED is going to take output from number 13 to the LED, hook to the resistor, and then the resistor is going to hook back to ground. And that so it's nice and square. Yep, just a simple circuit, LED, current limiting resistor, back to ground. The switches, we're going to start with 5 volts, and we're going to pull off 5 volts and connect it to both of these resistors. We're going to connect both of these resistors to a switch, and then we're going to connect the back side of both of these switches to ground. And finally, we're going to need to hook up some digital things to measure these switches. And these are going to hook in between the resistors and the switch. So for this circuit, 5 volts is going to come out of a fixed output on the Arduino and be split between these two resistors. The other side of these resistors is going to be measured by our Arduino through ports 2 and 3. Then we have our switches that, if they're closed, will be tied back to ground. And these switches are just simple push buttons. They've got 4 little prongs, and they're either open where none of the prongs are connected, or they're closed to where all of the prongs are connected. So if you've ever heard of switches with poles and throws, these push buttons could be considered single pole, single throw switches. Now, for switches, when you're using poles and throws, poles is how many individual circuits or loops could I control with this switch? And a single pole circuit can only control one. And that's true for these push buttons because they can only take one input. If you connect multiple loops into one of these circuits, they'll be connected to each other when you close the switch. So a double pole switch would be able to take 2 separate inputs and keep them separate. Now this is also a single throw switch because the number of throws for a switch like this determines how many different outputs it can be sent to. And a single throw switch is either open or closed. It's either sending things to the output or it's not allowing any current to pass at all. If you have a switch that could send the current to either the left side or the right side, that would be a double throw switch. But these simple push buttons, which are either on or off and can only take 1 loop's worth of input, would be single pole, single throw switches. So we've got this all hooked up. And now let's move over to the sketch to see how it's programmed so we can actually get input from these push buttons in order to control the LED. So starts off with standard explanation header, and the first thing they do is define the button pins and the LED pin as constants at the start of the program so that they can just be used all throughout the program, substituting for their numbers. Next, in the setup section, they set pins 2 and 3, the button pins, to receive digital input, and then they set the LED pin 13 to act as an output. So you've initialized all of the pins that are going to be used in this as either input or output. And then we start the main body of the program. So the first thing they do is they define a variable for the state of button 1 and the state of button 2. They define these two variables, and using this comma means you can define multiple variables of the same type using a single line. Otherwise, this is equivalent to if you were to say int button state semicolon int button state 2 semicolon. Those two expressions are equal. So we'll go back to the default state where it's comma. And then they're going to use this digital read command. Now, like the digital write command, the digital read command says, at that point I'm looking at, do I have ground or 5 volts? And it's going to give high or 5 or whatever if it's at 5 volts, and it's going to return ground or low if it's at ground or 0 volts. So we're going to read from pin 2 and pin 3 whether or not these pins are currently grounded. So if we go back to the schematic for a second, we are reading from here and here. So if the switch is closed, one of these switches is closed, then this measuring point is effectively going to be tied by a closed circuit, wires, no resistors, no nothing, to ground. So when this switch closes, these two pins should read ground or low. When these switches are open, it should pull the 5 volts. This resistor is basically to act as a stabilizer so you don't fry your board pulling too much current through it. But when this switch is open, it's going to read the 5 volts here and across these resistors, as this is a high current in this, or a high voltage state at this point. Not necessarily a high current, but a high voltage state. So when the switches are closed, it should read low, and when the switches are open, it should read high. So back over to the sketch. And basically, they talk a lot about when they're having these things. But they write a big, complicated if statement to demonstrate some logical conjunctions. And they state, if this big, long, complicated if is true, then turn the LED on. Otherwise, turn it off. So let's parse this big, long, complicated LED thing. Or let's parse this big, long, complicated if statement. So, if button state 1 is equivalent to low, or, and this pair of lines is an or operator, button state 2 is equivalent to low. So, this first half is going to check, am I pushing button 1 or am I pushing button 2? And this will return, this fragment of the if statement will return true if I'm pushing button 1, button 2, or both of them at the same time. And then after it says to check that, it also includes and. So first it's going to check if I'm pushing one or both. And that will return true or false. Then it has an and conjunction. So that means if the previous condition is true and the next condition is also true, then the entire if statement will be true. So the next condition starts with not. So whatever's in these next parentheses, this not operator will invert it. If it was going to return true, it will now return false. If it would return false, it will now return true. So what this one is asking for is button 1 low? Has it been pressed? And has button 2 returned low? Or are we pushing button 2 down? So this second thing is asking, are we pushing buttons 1 and buttons 2 at the same time? If we are, return true. Otherwise, return false. Except this is immediately preceded by a not statement, or a not operator, the exclamation point. So, instead, it's going to return true as long as both buttons are not pressed. So, if neither of them is pressed, or if only one of them is pressed, it's going to return true. And the first condition will return true if either or both is pressed, and the if statement as a whole will be true if both individual conditions are true. And compounding all of that together, the states under which this if statement will be true is if one of the buttons is pressed but not the other. So this particular set of logical operators, which is condition 1 or, and, not, and, creates a sort of exclusive or. An exclusive or operator says return true if one of my two inputs is true, but not both. So this big, complicated if statement essentially substitutes for an exclusive or operator, which doesn't have a nice, quick little logical operator like and, or, and not do. You've just got and, or, and not. So that's how you can sort of conjoin and, or, and not statements to create an exclusive or check, even though you don't have an exclusive or direct command. So, this whole program boils down to, if I'm pushing one of my two push buttons, but not both, turn the LED on. Otherwise, turn the LED off. So let's upload the program, go over to my circuit. As you can see, we've got our LED here, and we've got a pair of push buttons here. And now these push buttons do not attach well into the breadboard. They're rather loose and shaky, so when I push them, things might not turn on immediately or turn off immediately the way they're supposed to. This is not the best way of showing this, but the push buttons do work and the circuit does work for the most part. So if I go ahead and push this one button, light turns on. I go ahead and push this other button, and then push it down harder to make sure it's actually sank into the breadboard. Light turns on. And yeah, you can see it wobble as I pull my finger off. So push one button, and yeah, it's not cooperating, but there, light's on. And then I go over to push the second button, light turns off. Release one button, it turns back on. Push the button again, it turns off. Release a button, it turns on. Push the button, it turns off. And then the push button pulls out of the circuit again, and I have to reseat it before going again. But as you can see, the circuit works when you're pushing one button. I think I'm out of alignment there. The light turns on. One button out of the two, the light turns on. But if you push them both in, light turns off. One thing that isn't exactly covered in this, which might be covered in a later video, is you'll notice sometimes that the light almost flickers a little bit when I'm pushing them both in, or that I can't push them quite in at the same time. and there could be some flickering and flashing. There is some internal switch bounce whenever you switch or whenever you actuate a switch. So for a brief time, much briefer than I can really see, or you could see on this video, when I push that switch, it's going to be bouncing between on and off very, very rapidly. And this program doesn't particularly care, and you'll never see it because the LED will be blinking faster than you'd be able to tell. But in other cases where you might need very, very clean and precise switching, you'll need to implement some corrections to make sure the fact that your switch doesn't actuate perfectly every single time doesn't cause ripples in your output. And that's it for switches and push buttons.